Hi everyone, welcome back to another video on the channel. In this video, we are going to continue our DSA series and we will solve another problem in this video based on the concepts that we have learnt in the past 2-3 videos on the topic that is numbers theory of the DSA section. So in this video, our aim is to solve the palindrome problem where we will be checking if a number is a palindrome number or not. In case if you don't know what is a palindrome number, then a palindrome number is a type of number where if you reverse that number, it is exactly same as the original number. Let's consider an example that is 121. If you reverse the digits of 121, then you get the same exact number back. So that is basically the palindrome number. And we have to apply some algorithm to find out the number is palindrome number or not. So our algorithm will work in such a way that first of all, we will store the original number in another variable because we are going to perform some operations on the original number, such as extracting the digits, then making the reverse number out of it. So, in order to do that, we have to do some operation on the original number. So, that's why we are going to store it in another variable so that we can check at last if the original number is equal to the reverse number or not. Then by using the original number which is given, we have to calculate the reverse number. We have already discussed how to get the reverse of a number in the last video. In case you haven't checked it out yet, I will be leaving the link in the description. Then at the final step, we have to check if the original number is equal to the reverse number or not. If the answer is true, then we have to print or return true. If it is not, then we have to print that the number is not palindrome number or return false according to the return type of the problem. So if you have forgotten the reverse number logic, let me just summarize this in a few minutes and then we can solve the problem. So in reversing the number, we basically followed this algorithm. First of all, we have to get the modulo 10 of the given number to extract the last digit. Then we have to multiply the number with its place value. And in the decimal number system, every place value is increased by 10 times. So we multiply 10 with the reverse number that we get or the reverse digit that we get. Then we add up the digit that we got in the current iteration. In the first iteration, our reverse number is 0 because we haven't traversed the number yet. So the initial value of the reverse number is 0 and we got the first digit as 9. So we have to multiply the reverse number with the place value that is 10. Then we have to add up the last digit we have extracted from the given number. So if we do that, our answer is 9 for the first iteration. Then we have to divide the number by 10 so that we can extract the next digit in next iteration. So if we divide the number by 10, it becomes 778. Then we again modulo 10 it to get the next digit that is 8. Now our reverse number is 9, not 0. So we have to multiply the place value 10 with 9 and then add up the digit that we got over here to get 9 into 10 plus 8 that is equal to 98. Then again we have to divide the number by 10 to extract the next digit. Then again in the next iteration, modulo 10, multiply the previous value of reverse number with place value that is 10, then add up the new extracted digit to get the reverse number. At last, we have to continue this iterations until our input number becomes 0. At last, we got our final reverse number here, that is equal to 9879, which is the, sorry, I have written, I think I have written the wrong value over here, but if we do the operation, we will get the actual reverse digit, that is 9877. So this is the logic. We have to continue until the number is not equal to 0 or greater than 0. We have to extract the last digit by modulo 10, then multiply the place value or 10 with the previous reverse number, then add up the last digit that we have extracted, then divide the number by 10 to extract the last digit. As the number gets divided by 10 or reduced by 10 in every step, so the algorithm of the function is of time complexity log of n. And in the palindrome problem, we also have to do the same operation again to reverse a number. So that's why our time complexity over here will also be log of n plus 1, because at last we have to check if the original number is equal to reverse number or not. That's why we have plus 1 over here. But if we check approximately, the time complexity of both these problems are similar and exactly same, that is log of n. Now we have to move into the gigs for gigs code editor and code out the problem. So it is an easy level problem. So what we have to do is that we have given a input number n. Consider this example. Here n is 555, and obviously it is a palindrome number, because if we reverse 555, we get 555. So output is true. Here we have to return the Boolean value, that is the number is palindrome or not. And here in the second example, we have 1, 2, 3. If we reverse it, we get 3 to 1, which is obviously not a palindrome number. So that's why we return false. Now, let's write the logic. First, let me calculate the reverse number first. Uh, we declared a reverse variable first, then while our number is not equal to 0, we have to extract the last digit of the number by doing modulo 10. Then we have to multiply the reverse number in the previous iteration with the place value, that is 10, then add up the last digit that we have extracted over here, then divide the number by 10 to get the next digit, and we have got our reverse number. But as you can see, we are doing the operation with our original number and dividing it with 10 in every step. Will it be same as it was given in the function in the first place? Let's consider we have been given 1, 2, 3 as the n value, and we have been it dividing it by 10 in every iteration. At last, when we got our reverse number, will the n value be same as 1, 2, 3? No, right? It will be divided by 10 at every step, and we will continue this reverse number logic or the loop until n value not becomes 0. So at last our n value becomes 0. So here if we do comparison, like if n is equal to reverse number, then return true, then our logic has an loophole, because here n becomes 0. At last n becomes 0. So we cannot do that. So that's why we have to use a another variable over here to store the original number, so that we can compare it with the reverse number that we get in the last step. Okay. So if our original number is exactly same as the reverse number, we have to return true. Otherwise, we have to return false. Now we will hit the compile button. As you can see, the test cases have been passed successfully. I will just submit the button, and as you can see, all the test cases have been passed. Our attempt is correct. So thank you for watching this video. I hope you understood the palindrome number concept. If you have any doubts regarding this video or any previous video, you can reach me out in the comment section below. I will be happy to answer your questions or doubts. So thank you again and keep watching